this is section 10 of chapter 9. And this section talks about how to find missing pieces of segments if the intersection is happening outside the circle instead of inside. Okay. Yesterday we talked about two chords intersecting inside, and that this is A, B, C, D, that A times B is equal to C times D, right? Today, they're not going to intersect outside or inside. They're going to be two secants that are intersecting outside the circle. Okay, today we're just going to concentrate on secants. Secants, if you remember, go through the circle in two places. Tangents touch the circle in one place. That's the difference between secants and tangents. Okay, so tomorrow, or not tomorrow, I'll talk about the schedule in a minute. The next section, section 11, we're going to talk about when one's a secant and one's a tangent, what we do. Today, we're just going to focus on two secants. Okay, so if this is A, and this is B, and this is C, and this is D, I'm just breaking up that secant line at the point it intersects the circle. Okay, what we do to set an equation up, we take the external piece of one secant times the whole length of that secant. And that's equal to the external piece of the other secant times the whole piece of that other secant. Okay, so if I put in some actual numbers here, I'll leave A as a variable. I don't know if it'll work without being a decimal, but I just made them up. So I'm going to take 3 times the whole length, which is 3 plus A. And that's equal to 7 times 11. The whole length is 7 plus 4. You follow that? So this becomes 9 plus 3A equals 77. 3A equals what? 69? No. 68. So then divide. Is that right? Yeah. A is then 68 thirds. I figured it wouldn't turn out to be an integer, but okay. You also are going to have times, and I'll do this one here, see if I can figure one out. It's 4x, 12 and 8, maybe. So the whole thing's 12. I don't know if that'll work or not. Yeah, it should. Okay, so this time I'm going to have x times x plus 4 equals 4 times 12. Right? So I'm going to end up with a quadratic. So I have to solve it by factoring. And I'm looking for factors of negative 48 that equal positive 4. So 12 and 4. No, that's 12 and 8. Let's pretend this is an, because I didn't make up numbers well enough. Okay, so x plus 12, x minus 4, right? Set it equal to 0. So it's either negative 12 or positive 4. It would have to be positive 4 because I can't have a negative x. Does that make sense? Okay, I changed the number down here, so this should have been an 8. But that's really the section, just understanding that the outside piece of the secant times the whole length of the secant is equal to the outside piece of the other secant times the whole length. And this only works if those secant lines actually intersect. Questions on that? Okay, so 910 and 911, big ideas, is really just labeled as 910. I created it and then I forgot that We didn't do tangents and secants in this lesson. We're doing that in the next lesson. So there are some questions on big ideas that are tangents and secants, not just secants and secants. So you can just skip those until we go through that lesson, and then the whole assignment will be due at the end of that lesson instead of this one. Does that make sense? Okay. Tomorrow, you guys have ACT in the morning. Because I have my other section and fifth period, I'm probably not going to go on with you guys, so it'll be a work day tomorrow anyway for you. Okay, and then no school Friday. So Monday, we'll be doing 9/11. Parent-teacher conferences are this week, so Friday is a day off for everybody.